All right, well, happy Friday, and I hope you guys are well. This is Friday of week 5, so this kind of marks our halfway point in the quarter, and I hope you guys are doing okay. Let's see. Today's topic, we're going to continue talking about pandas. Pandas is going to be the kind of primary way we interact with data when we're working with Python. So we introduced NumPy last week, and this week we brought in we're talking about pandas, which brings in the data frame. Okay, and so I'm going to start off by just kind of importing NumPy and pandas, the standard form. Import NumPy as NP, pandas as PD. And for today's lecture, we're going to be working with indexes. Okay, so pandas. So in R, you have data frames, and data frames are important, but they don't have this index feature. And I think the index feature in pandas is something that makes it really nice and kind of a joy to work with. But you gotta just be you gotta get accustomed to it. Okay, so anyway, I've got these two series here. Okay, this one is 1.4, 2.3, 3.1, 4.2. Okay, this is in order from least to greatest, and the 0.4, the part that comes after the decimal, corresponds to kind of the index letter. So the 0.4 goes to the D. The 0.3 goes with the C, the 0.1 goes with A, and so on and so forth. Something similar over here, except these are not in any order. We got 2.2, 3.1, 1.3, 4.4, and again, the number that comes after the decimal aligns with the index letter. Okay, and so here we can make a data frame, all right? And if you make a data frame here, I'm just taking the original and multiplying original by 2. So both original 1 and original x2, which is the original 1 multiplied by 2, they both have the index in this order DCAB. Okay, DCAB. And so so when I produce this data frame, it comes in with the order DCAB. All right, so it preserves the order of the data frame. If you're kind of linking together series that have the same series, same index order, it's going to preserve that original index order. Okay. Note that this series does not have the same order. It's BACD, and so if I put these two series together, original 1 and original 2, where the series are in different order, original 1's DCAB and original 2's BACD, then what Python will do, or what Pandas does, is it takes a look at the index, it sorts it, okay? It sorts the index, A, B, C, D, and then it links them up accordingly, okay? And you can see all of the values got rearranged. So now that it's A, B, C, D, all of these have 0.1, 0.1, 0.2, 0.2, 0.3, 0.3, and 0.4, 0.4. Okay. When you ask for a series and ask what is the index, okay, the index comes back in a pandas index, and it's kind of like a tuple. It's kind of like a tuple in that you can kind of ask, there's a specific order, all right? But it's also, you can't just kind of mess around with it directly, okay? When you slice a series, okay, I'm going to say slice from index D to index A, okay? It goes in the original order of the index, DCAB, okay? And it includes the first and last elements there. However, if if we look at the data frame, remember when we created this data frame, df, we put original 1 and original 2 together, and so when it joined them together, it rearranged the index into alphabetical order, A, B, C, D. And so now, if we were to slice this, it uses the index order A through C. This one uses the index order of the data frame, which is sorted, okay? And I think that makes sense, right? When you ask for slicing the series, it's going to use the order that appears in the series. Over here, it's going to use we're slicing the data frame, and it's going to slice the order that appears in the data frame. And again, when you're slicing a data frame, you can just kind of provide the indexes, and it's going to provide the corresponding rows. Okay. With the series, they both have these methods. Both Pandas series and data frames have a .sort index and a .sort values method. Okay, so here's one of the series. Okay, and neither the index nor the values are sorted. So I can just do sort index. Okay, and it gives us A, B, C, D. And I can also do sort values. Okay, and this will arrange them. As you would expect, this arranges the index. Arranges the series based on the index sorted, and this arranges the index based on values sorted. Okay. Here's the data frame. If you do .sort values, you can specify which column that you want to sort on, and you can say ascending true or false. So ascending false will put sort based on column X in descending order, and I think that's expected. Oh, you know what? Let me pull up the view quiz answers. I'll keep talking while I'm looking up our view quiz answers. All right. When you work with the index of a data frame or a series or data frame, the index itself, the index object is immutable and it can't be modified. So you can't just come in and say, you know what, I want to change the index from ABCD to GFG or or EFGH or something like that. Okay, you can't just modify the index. But what you can do is you can replace the index of a series or data frame with an entirely new index or data frame or series index. What did I say? You can take the index of a series or data frame and just replace it. Okay, so you can't take the existing index and modify it, but you can take the index and just replace it with something else if that's what you want to do. So I can take that index and I can just kind of remember the original index for original 1. Where did it go? Way back here. Okay, original 1. The index is DCAB, and my values are 1.4, 2.3, 3.1, and 4.2. So let me... So what I can do is I can take original 1.index and just replace it. Okay, replace it with range 4. And it used to be, I think, DCAB, and now it's 0, 1, 2, 3. It still kept the original order of DCAB. Okay, so we can see 1.4, 2.3, 3.1, and 4.2. It just, all we did is we just threw away the old index, or we just replaced it. Okay, and when you take something like a range object and assign it to an index, Pandas will convert it into what's known as a range index. Okay, so a range index basically behaves kind of like a range object, but it serves as an index with kind of all of the properties of an index, making it, immutable and things like that. Okay, sorry, let me look up today's view quiz. All right, so your first view quiz answer for today is the letter E. E as in elephant. E as in elephant. Week 5 Friday, first view quiz answer, E as in elephant. E as in elephant. All right, and so now if I subset the series using square brackets, this is using the range index now, right? So range index corresponding to 1 is 2.3, and I can get this, okay? Dot location is the same thing. Using square brackets uses the index value. And here, because the index is also a range index that starts at 0, iLocation, okay? Selecting iLocation is also going to give us the same value, okay? Because iLocation always uses a range index starting at 0. Here, I'm going to just replace the index again. We're completely replacing the index with a new range object starting at 1, 5. And so this is kind of the way our numbers rose, right? It starts off at 1, and we go 1, 2, 3, 4. And so when you ask original 1, okay, and dot location, these both correspond to the index value being 1, which is 1.4, whereas iLocation always uses a range index starting at 0, so it would correspond to the second row, okay? And so this is going to be 2.3. All right, so just be mindful of this, especially if you have numeric values in your index, and especially if they are not starting at 0, okay? So, say if you import something from R, and you kind of use row names or something, row numbers as your index, which is not an uncommon practice, just keep in mind that dot location and dot iLocation are going to behave differently, okay? Whereas kind of your default data frame, if you use just a range 0 index or index 0 range object, these two things are going to behave the same. Okay. Here, if we say give me the value corresponding to index value A, okay, we get an error, right? Because A is no longer part of the index. When we first defined original, we had DCAV, but then we completely replaced that index. And so now if we say, hey, give me something that corresponds to A, we get an error. And unfortunately, when you get errors in things like Pandas, and when you get errors in NumPy, when you get errors in these packages, the errors that Python throws get a lot more complicated. Okay, so we get a key error, but then you get this big long traceback because it's saying all kinds of stuff. There's a little bit of a clue as far as where the problem is lying. If you look at kind of the name of the package or the name of the file that's being used, where it throws the error, right? So here it says series.python. Okay, so this indicates that there's a problem with the series. Over here it looks at range. Okay, so it's saying you got some kind of issue with series. Okay, and that's where it's running into an error. So hopefully you can figure this out. So you look at this line and you look at this and try to put it together. Unfortunately, the Python errors are generally very helpful when you're writing your own code, but then when you're loading in libraries and modules and packages, sometimes the error messages get a little more confusing. Okay, and again here I'm just replacing this entirely with a new index. I give it a list of values A, B, C, D, okay, which is very different from the original, which was DCAB. And so now ABCD kind of goes with this, okay? So you got to be careful because Pandas doesn't go in and check to see if the new index that you're using to replace the old index, if that if there's any kind of matchup or anything like that, right? I could have just put in any other arrangement of letters, and Pandas would have accepted it. As long as it had a length of 4, because my series has a length of 4, this would be fine, okay? An interesting thing that happens is that when you have strings as your index, okay, Pandas will now accept the string names like A to pull out the object, okay, and it will now also allow you to put in integers. And if you put in integers, it'll use a 0-based range index, okay, zero index. I don't know, starting at 0 range index, right? So now I can call in original 1 square bracket 0, and it'll give me the value associated with the 0 index position. Okay, so this only works though if you have an index that's strings. Okay, if you try to give it here, I'm going to try to replace the index with a list of length 5, 1, 2, 3, 4, 5, and it says you can't do that. Okay, you can't do that because it needs to be the same length. And again, if you try to read the errors, this one's a lot harder to understand, right? Generic.py, properties.pyx, series.py. This is a lot harder. Okay, it doesn't. You know, I've written the comment that it's a different length, but it's not quite clear from this error. Okay, you can change the index of a data frame just by kind of assigning a new index value here. So here I'm just saying, okay, let's go JKLM, and it says okay, I've done it, and that's that. Okay. Now, there's another thing that you could do with Pandas series and data frames and these objects, and it's called reindexing. Okay, and students often get confused because because there's a package, or not a package, there's a function called reindex, right? And a lot of times you think like, oh, you know what? I want to change the index. And so you think that this is reindexing, okay? But I showed you what changing the index looks like, and it's just you take a new thing and you just assign it to the index. You just take the new thing and you just throw away the old index and you put the new thing in. That's not reindexing, okay? Reindexing is taking the current index, all right, and then modifying the object, okay? Well, I guess creating a new object that's going to conform to this specified index, okay? And that sounds weird until you start seeing some examples here, okay? So it'll best be explained by showing you some examples, but don't confuse reindexing with just replacing the old index. So again, here we're going to go back and create our original series, 1.4, 2.3, and the index is DCAB. Okay, so here it is. Here's our original series. And I'm going to create an entirely new object, okay? And this is original.reindex, okay? So I'm taking this original series and I'm going to reindex it, okay? And so this is going to create a new object, and the new object is going to conform to this index that I'm providing. And notice this index has 5 values, A, B, C, D, E, okay? And here I'm not trying to replace the index here. We're gonna, this original object is gonna just stay as is. We're creating an entirely new one that conforms to this index, and what this is gonna do is it's going to take the values and rearrange them and have this new series conform to this to the index that I've provided here, okay? So it has now aligned at A, B, C, D, and then now that there's a value E here in the index, it doesn't throw an error, it just says, oh, you know, I don't have a value that goes with E, and so there it puts in a nan, okay? So if you try to just replace the old index with something like this, you're gonna get errors, right? Because you're putting in 5 values when the index is only gonna allow for 4. And so this is what reindexing does. Okay, so you go, oh, and then here is If you don't want nans, you can specify a fill value with 0 or something like that. Okay. All right. So you might wonder, like, why would I want to do something like this? Okay. When is reindexing going to be useful? Okay. So you might have some kind of ordered data, maybe like a time series or something like that, and you know, maybe you've only taken measurements at certain points in time. So we're going to say, you know, we took a your question.
Oh, so is this new object a copy of the original, or
It's just a completely new object. It's separate. It's separate from, like, if I were to call back just original, okay, it's going to still be unaffected. It's still going to be this thing. Okay, so this just creates a new object. I guess you could think of it as a copy, but you know, because a copy just creates a new object with kind of like no ties to it. Okay, so here I've got a series. The index values are 0, 3, and 6. So it might be like, you know, we took a measurement at you know, time 0, and then we took a measurement at time 3, and it took a measurement at time 6. And what we might want to do is we might want to turn this into, you know, kind of a standard range object that goes 0, 1, 2, 3, 4, 5, 6, 7, 8. And so we can re-index this with a range 9, okay? And it will link up blue with the 0, purple with the 3, yellow with the 6, and then here I've got nans for everything else, okay? And we might want to say, you know what? let's fill in the nans. And you know, we could specify a fill value, like, you know, 0 or blue or white or whatever. You can also fill in the values using forward fill. Okay, and what forward fill is it kind of pushes values forward until a new value is encountered when it's doing this. So all of those blues get pushed forward into positions 1 and 2. Purple gets filled in for positions 4 and 5, and so on and so forth. So that's forward fill. Okay. And then there's also backfilling, which works in the same way, but just in the opposite direction, okay? And so yellow, which is at 6, will fill in the nans that were at position 5 and 4. Purple gets filled in backwards into the positions 2 and 1, okay? And then there's nothing to fill in here, so these will remain nans. Okay, and that's backfill. Forward filling and backfilling, and this is often a desirable thing. Let me just show you kind of maybe a more common application or usage is using dates as some kind of index, all right? And, you know, I recommend looking up the help function for pandas.date_range, okay? Date range will allow you to kind of create these range objects formatted as dates, okay? And so keep in mind, I talked about this, maybe not. Are dates numeric or categorical data? What do you guys think? So maybe I haven't talked about it. So a date is actually numeric data, okay? Date is numeric data, even though it's formatted in this weird kind of way, right? Like today is February 4th, 2022, right? And that seems like, how is this numeric? Because, you know, certainly the month sounds like it's categorical, right? January, February, March. These don't sound like numbers to me. But it's actually, you know, it just kind of, time continues to flow every single day, and we just as a collective society and humanity have agreed upon some standardization of how we measure time, okay? And so we said, you know, there's, you know, some zero date, okay? And, you know, the Gregorian calendar is based on, you know, a date of religious significance, and we basically said, you know what, we're basically just counting how many days have passed since, you know, 1/1 year one, right? January 1st, year one. And it's like how many days we passed, but we're gonna, because of, you know, properties of the earth spinning around the sun, we're gonna say like every 365 days, we'll kind of like group that together into a thing called a year and stuff. But basically we could, you know, kind of just say, I don't know, 2022, you know, times 300, you know, it's been X thousands of days since this one point in time. And we just kind of agreed upon this thing. And so if you actually look at dates, they are stored. You encountered this in your homework assignment when you were looking at days since the epoch, okay? And so basically dates are stored as just days since this epoch date, which was, you know, arbitrarily agreed to as January 1, 1970. And therefore we can take two dates and take a difference between them, okay? And we can take, you know, multiple dates and take averages and things like that. And so, so they are numeric values. Okay, but anyway, we can create these date time index. And so here, we're gonna just start with January 1, 2010. We're gonna say I want six periods, and the frequencies will be daily periods. So it'll be January 1, January 2, January 3, etc. to January 6, okay? And in here, I'm gonna create a data frame, and this data frame will have some prices. We're gonna put in 100, 101, 100, you know, missing value, so on and so forth, okay? And again, the way we specify missing values in Python is by using a nan value, and we can do numpy.nan. Okay. So here I've got a data frame. Wait, let me just. Okay, I'm just repeating the exact same line. Okay, and then in here I'm going to just create another index. Okay, and this new index. All right, we're going to take this and we're going to this index starts December 29th, 2009. So it's going to start 3 days before January 1st, 2010. Okay. And what I'm going to do is I'm going to just re-index this, and all this does is it just fills in nans for those 3 earlier days, and then we also I guess it goes until January 7th, and so it fills in a nan here. So it takes this thing and it conforms it to this new index that I've provided. Okay, using re-index. Re-index is what we're doing. Now, what we can do is we can do something like backfill, and it's going to fill in the missing values backwards. Okay, notice it doesn't fill this one in. Okay, this missing value on January 3rd was part of the original data, so it only backfills missing values induced by re-indexing. Okay, so when I did re-indexing, it produced these missing values and a missing value down here. This is not a new missing value. This is a missing value from the original data. So when I ask for backfill, it only fills in the missing values induced by re-indexing, and it's not going to fill in the missing values from that was part of the original data. Okay. This might seem a little bit funny, but if there's no kind of missing information that kind of needs to be filled in, re-indexing and asking for the location end up working quite similarly. So here is, here's our a data frame where we've got the index and the values, okay? And I could say re-index the data frame to conform to this index that I've provided, ABCD, all right? And there's no missing values here. There's nothing, so it works fine. I could also just say, hey, give me the data frame and return the values at these locations, and it's going to give me the exact same thing. Okay. If I do give it something with missing, all right, re-index, and I give it A, B, C, D, E, re-index is fine, and this gives me nan. Whereas if I try to do it with dot location, it throws an error. Okay. So if you know you're going to be inducing kind of a value that might not exist in the position, then don't use dot location. Dot location, the only arguments you should pass into dot location should be values that you know are index values. Okay, if you pass it something that doesn't exist, you're going to get an error. Let me go ahead and give you your second view quiz answer for today. Today's second view quiz answer is the letter A. A as in apple. A as in apple is your second view quiz answer. All right. We can remove rows or columns at certain index locations, so we can just kind of drop these things. And this is different from subsetting. This is entirely just killing these rows. Right? So here, I'm going to take just we're going to take a NumPy range object, so 0 through 11, a range 12, so 0 through 11. We're reshaping it into a 3x4 NumPy matrix, and we're going to throw that into a data frame where the columns have the names A, B, C, D, and the index and the rows will have the index X, Y, Z. Okay, and the closing parentheses is missing, but we have that. Okay, so here we can just say throw away the rows X, and Z. All right, and so this is what we get. Okay, now when you call df.drop, the original data frame is unaffected. Okay, it's returning a new object with the rows dropped. So when I call df.drop xz, it throws away X and Z here, but then later on, if I call df.drop columns BC, okay, now to specify that you want to drop columns, you have to do axis equals 1, otherwise it's going to look for rows B and C, and it'll throw an error, okay? And so when I say, later on I say throw away columns B and C, it still has rows X and Z. They didn't actually get thrown away in DF, right? So it's giving me back a kind of a copy of the data frame with these rows or columns dropped. Okay, and again, this is just to show that the original thing is unaffected. So if I later on ask what is DF, it's still unaffected. When so this is where I think the beauty in Pandas and having an index is really nice, is that when you do arithmetic, Pandas will align the index first, okay? It's going to do element-wise arithmetic, but it's going to first align the index before doing any kind of computation. All right, so here I've got a series A, C, D, E. Over here I've got another series with index A, C, E, F, G. All right, and so here if I were to line these two things up in a data frame, we can see where things line up, A, C, D, and then E, F, G, and then there's, you know, a missing value over here and missing values over here. And if I were to just take the series, and this is just for reference, I'm not adding columns in the data frame first. I'm just taking two series and I'm saying add them together, okay? And when you add them together, you can see that it's aligning the A with the A, and it's aligning the C with the C and the E with the E, and it gives us results for those things, right? So here E was 1.5 and E is negative 1.5, so we're getting zeros, and then we get 5.2, 1.1, and so on and so forth. And then, of course, whenever there's a missing value and we say, hey, add something to a missing value, it's always going to return back a missing value. Okay, another way you can do this is you could do series 1 dot add series 2, and you get pretty much the same result, series 1 dot add. Now, why would we want to, okay, sorry. So yes, so why would we want to do dot add versus just say the plus operator? Because the plus operator is certainly easier. We would be more accustomed to it. Well, whenever you use the dot add or dot subtract here, okay, you can specify additional arguments, whereas using the plus operator kind of is going to be the default addition or default subtraction. And so here I'm going to specify a fill value, and I'm going to say, hey, do this operation. Do S1 minus S2. S1 subtract S2, but use this fill value, use a fill value of 0, meaning whenever it encounters a nan, just fill it in with 0. Right? And so now we're not going to get any kind of missing values here. Okay. There is also a R sub. R sub is right-hand subtraction. So when you do S1's R sub S2, that would be the equivalent of doing S2 minus S1. Okay, so that's right-hand subtraction. Normally, we're accustomed to left-hand subtraction, which will be S1 minus S2, but you also have R sub. Okay, and so R sub is going to just return the negatives of everything in left-hand subtraction. Same thing. Here's the multiply operator. So you can do S1 star S2 for element-wise multiplication. And similarly, you can, if you do S1 dot multiply S2, you can specify something like a fill value for missing things. All right, so here are 2 data frames. Okay, data frame 1 has rows Ohio, Texas, Colorado, and columns B, C, and D. And data frame 2 has rows Utah, Ohio, Texas, Oregon, and columns B, D, and E. And similarly, when you do arithmetic between data frames, it's going to align the indexes and return values for these things. So, I have no idea what these numbers even represent. They're just arbitrary numbers, okay? So we just filled them in. So here, if I do data frame 1 plus data frame 2, it aligns the row indexes, it aligns the column indexes, and it returns values where things line up, okay? And so really the only ones that had values in both data frame 1 and data frame 2 were Ohio, columns B and D, and Texas, columns B and D, and it added those values up, okay? Again, if you want to have things filled in, you can specify a fill value by doing df1.add, and it will replace all of these nans with basically zeros, with the exception of locations where it was missing in both. Okay, so Colorado E does not exist in either data frame. Oregon C or Utah C does not exist in either data frame, and so those remain as nans. But everything else, it kind of filled in as 0 and it added them accordingly. Okay, so all of these things are operators that can be called on data frames in series, and so basically you have addition and subtraction, multiplication and division, and you also have the right-hand versions of those things. Okay, you also have floor division, and you have exponentiation, which is dot power. Okay. Along with the right-hand versions of those things. Now, it feels a little strange having a right-hand multiply and a right-hand add, because we always think of these things as commutative, but they do exist. Okay, so let's take a look at some of the summarizing abilities of a data frame. So you can take the data frame and call dot sum, okay? Now, with Pandas data frames, dot sum is going to have the default behavior of just ignoring the nans, okay? Or basically using zeros as the nans when it adds them up, okay? You can also sum by specifying the axis. So the normal, it's going to do axis equals 0. And so it's going to sum, axis 0 being the rows, it's going to sum across the row. You can also say sum across axis 1, and this means it'll sum across the columns. Okay, so axis 0 is rows, axis 1 is the columns, and summing is going to basically say collapse that column. So sum default would be sum axis 0, collapse axis 0, collapse the rows into basically one value. Here, collapse the columns with axis 1 into some things here. Okay. You can also say, I don't want you to skip the NAs. Okay. You can say, don't skip the NAs, skip NA false, and now we get nans because we encountered nan values. Similar thing with means. You can specify df.mean. The default is axis 0. You can also specify access 1. Other operators is give me the minimum, give me the max, things like that. Okay, so say find the minimum, find the max, find the median, all of those things. There's an operator called idxmin, or a method, idxmin, and this will say which row or which value has the minimum. Okay, which value has the minimum, and it returns the first value that it encounters if there's ties. Okay, so here it says for column 1, the minimum exists in row A, 1.5. For column 2, the minimum exists in row B, negative 4.5. That's what it's saying here. Okay, and so these are some of the summary values. You can ask for the count or the quantiles, the sum, mean, median, mean, absolute deviation. Okay, that's the MAD, the product, variance, standard deviation, and then there's more things that you can look up for kind of reference. But you can just take a data frame and just say, hey, give me the mean, and it's going to default to giving you the mean of all of the columns. Okay. Similarly, you can also ask for unique values. You can say take column 1, and notice I'm chaining these kind of attributes together. We're going to say from the data frame, column 1, give me unique values. Okay, give me the unique values. What are the unique values in column 1? And it shows you unique values in the order that it observes. So it starts at the top, and it says 1.5 is the first time encountering 1.5. Then I see a 6.5, and it shows that. Then I encountered a nan, and it shows that. And then it encounters 1.5 again, and it says, well, that's not a unique value, so it doesn't put anything. And then it encounters a 4.0, and then these other values aren't unique, so they show up in the order that they're encountered. Okay, same thing if I just called it on the other column. You can only call unique basically to a single column. You can't just ask the data frame and say, hey, give me the unique values total or something. That doesn't work. Okay. You can ask how many unique values you have, number of unique, so n unique. And this will give you the number of unique values that are non-missing. So if it's a missing value, it's not counted as a unique. Okay. This is a very handy function. Value counts, value underscore counts is basically going to just kind of tally up how many times a certain value it encountered. So it'll say it encountered 1.5 2 times, 6.0 2 times, and 4.0 1 time. And again, it skips anything that's missing. So how many times did a value is encountered? You can also get back a boolean value when you ask is in 1.5 comma 4.0. All right, so here df.1.isin 1.5 comma 4.0, and then you get kind of a thing of boolean values of whether the value in there. So again, looking at this, is the value in df1, in this kind of set of 1.5 or 4.0, and it's true for A, D, and E, and false for everywhere else. So that's what we get. If you, another way you could do it is you could do df1 equals 1.5 or df.1 equals 4.0, right? And this will also give you the same results, but I would say using the isin method is the preferred way to do this, right? So this will give you, and you can use the bitwise OR using the single vertical bar here, but this would be the preferred method for doing something like this. All right, and then and similarly, you can use that Boolean, this thing that where we get trues for A, D, and E, and you can use that to subset the data frame itself, right? So you can say df.location, you put in that Boolean, and you say I want these rows, and then so you put in a comma, give me back all of the columns, and it will subset the data frame accordingly. All right, we're almost done, but let me give you the last view quiz answer for today. Today's last view quiz answer is the letter C, C as in cat, C as in cat. All right. If you want to get rid of missing values, you can do drop NA. This will drop any row that has any missing values. So it only keeps totally complete rows. Okay. So it drops these 3 rows. There's an optional argument, how equals all, and this will only drop rows that are completely missing. So there's only, if you look at this, row C has nans for both columns. So you can say, you know what, those are the only rows I want to drop if it's nan for all of the columns, and it will also do that. Okay. You can also say, you know what, I only want to keep entries where, say, column 2 is not missing. Okay. So you can say df.2.notNull, and it will keep all of the entries where 2 is not null, regardless of what exists in column 1. Okay, we can fill in missing values. So you can fill it in with a constant. You can also kind of you can specify for column 1, I want the fill value to be here. So you pass a dictionary with where the key is the column name. So you're going to say data frame, fill the missing values. For column 1, fill in the value 1000. For column 2, fill in the value 0 or something like that, right? Okay. You can also fill in values using any of these other methods, backfill, forward fill, etc., etc. Okay. You can, something that's, I think students like to do, although I don't know if this is the best idea, is you can say, well, you know what, find the mean, right? And again, Pandas' default method is when you ask for the mean, it's going to ignore the missing values. And then so we get a value of 3.8 and 1.3. And this itself is kind of, it's not exactly a dictionary, but it's a series. So, when you use a series as if it were a dictionary, it uses the index name as kind of the key, and the value as the value. And so we can say, hey, df.fillNA, and it's a lot like kind of using the dictionary back here where we specified a value. Here we said 1000 and 0, but we could say fill in with the mean, and it's going to fill in 3.8 in those missing values and negative 1.3 for the missing values in column 2. Okay. All of these things, whenever we did fill NA, they create new data frame objects. You do have the option of modifying the data frame in place using in place equals true. Okay. Other methods for data frames, you can transpose them. And so if you want to fill in something with, say, the row mean, okay, you can do, so notice how we're going to do this, all right? So I can transpose this. I can say take the mean of df.transpose. So when you call .mean, it's filling in, it's going to calculate column means, and then we're going to fill it in that way and then transpose it back, okay? And that's what we have there. Okay, I'm out of time here, but I think there's only a few slides left, so I'll just leave it to you in your reading this weekend to go over some of these things, okay? Okay, so we will end here for today. Have a good weekend. We'll see you guys next week.